Hi, everyone. Thank you for joining us. Let's wait a couple more minutes for folks to join the call. Maybe one more minute for folks to join. All right, I am going to start since I don't want to keep you all waiting. Thank you for joining our webinar today. The topic is 3 to 1 Go. How fast can you debug issues in microservices? And as the name of the webinar suggests, we're here today to explore some tools that would help you accelerate troubleshooting in a microservices environment. As Splunk customers, you have easy access to these tools, so we thought that, that you would benefit from learning about them and seeing them in action. Before I begin, I would like to introduce myself and my co-host. I'm Ori Broyd, and I'm a Director of Product Marketing here at Splunk. Tanvi, would you like to introduce yourself?
Yeah, thank you, Ori. Hey, everybody. Thank you for joining us. I am Tanvi Sahani. I am a product manager with the Splunk Observability Cloud product, and we're both very excited to share what we know about debugging microservices. So, without any delay, we'll jump in.
Sounds good. So today's agenda is very simple. We'll briefly discuss the problem of why troubleshooting in microservices is so complicated. Then we'll spend the majority of the time on discussing solutions and showing you lots of demos. We'll finish with a summary, and then we'll leave time for Q&A. Before we begin, let's have a short survey or a poll of what is your mean time to resolve issues. Is it A, less than 10 minutes, B, between 10 minutes and 1 hour, C, between 1 hour and 4 hours, or D, more than 4 hours? We'll give you all some time to reflect and submit the answers. Maybe a couple more people. All right, let's see the results. So seems like it's evenly spread. Some of you have the MTTR is less than 10 minutes, which is great. But over 50% of the attendees are saying that it takes them between 10 minutes to 4 hours, and 10% more say that it takes them more than 4 hours. Don't know what the other category would be in this case, but hopefully we can help you all reduce your MTTR and get you to the less than 10-minute category. I think we skipped one slide. Yeah, I'm missing a slide. I don't know why. Anyway, so what makes this such a difficult problem, and why does troubleshooting microservices take such a long time? There are several reasons, and it's not just one single reason. So first of all, cloud-native environments and microservices generate a lot of data and a lot of alerts. So you need to sift through all that data and alerts to understand the root cause. And you need to know which ones of the alerts you should prioritize. A few more reasons is that many organizations evolved with having multiple monitoring tools, and those tools don't do a good job talking to each other. So you need to have a lot of context switches when you look at one tool and then move to the other, and that context gets lost. A few other things is that many tools were designed for 3-tier applications, and so they don't do a good enough job handling the amount of data that's generated by microservices, and they end up sampling the data, and the result is that you have gaps. And finally, the monitoring tools require you to develop expertise specifically for those tools, so it takes you time to learn how to get to the root cause. The good news is that you're not alone, and this is a very common problem. So every year at Splunk, we run an analysis that's called the State of Observability, in which we interview over 1,500 IT ops staff, managers, executives, engineers, and developers and SREs. And what we found is that 35% of companies have between 11 to 15 different observability or monitoring tools, and about 17% of companies have over 16 tools. That's a lot of tools to do context switching with, and because of all those tools and alerts that they generate, 57% of the respondents say that prioritizing the right alert is problematic for them. If these are the type of problems that you are also facing, then you're likely here because you're looking for solutions, and you're talking to Splunk because you rightfully think that we have answers and solutions for these problems. So in fact, about a year ago, we worked with Forrester, which is an analyst firm, to try to measure how well our observability solutions help customers. We reached out to them because we wanted to really get objective third-party measurements on how well we're doing. So the Forrester team went out and they spoke without us. They went out to speak with customers. We were not in the room. And they came up with a few numbers. And first of all, Splunk Observability helps reduce, with Splunk Observability, what they found is that the number of outages that our customers experience was reduced by 70%. In other words, you have way fewer outages and issues that you need to troubleshoot. the other thing that they found was that when there is an issue, Splunk Observability helped them reduce MTTR by 75%, so really accelerating their troubleshooting process. And then hopefully after this webinar, you can start implementing steps that would get you in that same direction. So with that in mind, that's the background. Let's show you how we can help you accelerate the troubleshooting process in microservices. So this is the slide that refused to show up earlier, and it lists the problems that I was talking through. And then let's focus on the first two. So getting a lot of alerts and that it's difficult to prioritize the right issue. Now, every application performs, every application performs multiple functions. And these functions are performed by having multiple microservices talk to one another. So in this example, we see one function of the application is leaving reviews and comments. Another function is being able to process returns. And a third function, which is arguably the most important, is placing orders. Now, all three of these functions have a few microservices in common. So if we just monitor individual microservices in a vacuum, we won't be able to understand the impact of issues they're having on the business. So what we want is to be able to say whether an issue in the sign-in service is impacting checkouts and hence revenue, or just leaving reviews, which is important, but we can deprioritize that for later. And that's exactly what we do with business workflows. This capability allows you to group together any combination of microservices in a way that aligns to the business function that these microservices perform, such as checkout or leaving your reviews or whatever it is that you want your application to do. And then once you've defined the workflow, you can have metrics for it, like the request rate, errors, and duration, and then set alerts if any of these metrics indicate an issue. Furthermore, you can filter the service map and tag Spotlight to view performance of just the business workflow that you care about. So with that, it's time for our first demo, and let's see business workflows in action. Okay, so let's start with the demo. You want to see business workflows. That's part of APM. And on the landing page of Splunk APM, you can immediately start by seeing both the top services with errors and latencies, and also the top business workflows with errors. You can see the list here, and P90 latency. You can also see both an overview of all the workflows and the services here, but that's not very visual. Like, it gives you stats, which are interesting and good, but if we want to see it in a more visual way, let's go to the service map. So this service map is generated automatically. And the first thing that you can notice is the solid red dot. And that means that this is causing root cause errors for the entire application. Each one of these circles is a microservice, and each one of these kind of square things is a database. Now you can see the dashed services and database. These are in databases. These are services that have not been instrumented, but rather they are inferred services. So Splunk APM realizes that they exist because of the traces that we collect. And this map is generated automatically, and it gives us a lot of information. So first, this is the entire application, and it has 13 services. Now let's take a look at the product info workflow. And you can see that that the service map is now filtered down to 8 services that together comprise the product ID page. Another workflow is the checkout one that has 12 services. You can see again the solid red dot is causing you issues. And for every workflow, you can see on the side requests, errors, error sources, duration, and P90 latency. And for each one of these metrics, we can also set a detector or an SLO to alert us if we're having too many errors or if the duration is too long. All right, so hopefully you found that helpful. Now, before we move on to the next set of problems, let's have another quick poll. And this one you can select multiple answers. So what is the telemetry data that you use for troubleshooting? Is it logs, metrics, distributed traces, stack traces, or anything else? I'll give you a few minutes to, or seconds to choose your answers. Few more, come on. Hopefully it's bright and early for you in the morning, or at least getting close to midday. So if you can add more answers, I think we're good. All right, so let's see the results. So not surprising, many of you as Splunk customers, you use logs, almost 85% of the attendees. And then metrics, which are very useful to get quick alerts. And then way fewer are using distributed traces and stack traces or other sorts of telemetry data. Now, in general, the more telemetry data that you have, the easier it is for you to pinpoint the problem earlier. But one of the things that we'd like to focus on now is that correlating the issues and correlating that telemetry data using multiple tools is not easy. Those tools are not really talking to each other because context gets lost. So what do I mean by that? Service owners, as the name suggests, a microservices-based application is composed of multiple microservices. But then, as a service owner, when we want to troubleshoot an issue in our service, I would usually only care about my service. So when I'm trying to troubleshoot that issue, I care about the telemetry data that's relevant for that service at the time frame that I'm looking at. I would want to see the logs, traces, metrics, profiling, and all the dependencies in one place, in context. What I don't want to do is to switch between multiple tools, and that might be one reason why we saw that many people use logs and metrics, but then it starts to drop off when we're talking about distributed traces and stack traces, because then we have more and more data that we need to correlate and preserve the context. So with that in mind, I'd like to talk about the rationale behind Service Centric Views. And it brings in all the relevant telemetry data into one place so that the service owner doesn't need to waste time switching between tools, doesn't need to remember the context and figure out which distributed trace goes with which logs and which metrics. You want it all to be together and tied to one another so that you can troubleshoot issues faster. So again, we don't want to just talk at you. We want to show you things in action. So let's take a look at what Service Centric Views does. And on the way, we'll also see Tag Spotlight, which provides a global view of how my traces are behaving, and Always On Code Profiling, which shows me how much CPU and memory each line of code consumes. Right, so now let's see what we can do about this solid red dot. And what that means is that payment service is at the root cause of these errors. So that's what the solid red dot means. And then if we click on payment service, then we can start getting metrics like service requests and errors, dependencies and latencies. We can see a lot of the things that are relevant to it, or we can go directly to Service-Centric Views. Service-Centric Views, like I said, has all the telemetry data in one place for payment service. So we can see success rate, we can see the dependencies, we can see the SLIs, service level indicators, requests, latencies, and we can also see things like runtime metrics or infrastructure metrics. And once it loads, we can see things about the host that this service is running on. So things like memory usage, CPU usage, network, hard disk, CPU, pod CPUs, etc. We can also go to Tag Spotlight. And what Tag Spotlight does is it takes data about the payment service and it takes all the traces for it and divides them based on the different tags like endpoint, environment, or in this case, a more useful things, the HTTP status code. And we see that some of the traces have a 401 error, and we know then that all the errors are this type. We can see that the tenant level, all the different tenant levels are impacted by the errors. And most interesting for us, we see that all the errors are originating only in version 10. So if we didn't have the log data, which I'll show you in a minute, then we'd know that this is where there's an issue and we can go and troubleshoot it. But since we have the logs in context here, we can actually go directly to it, to the logs, and see for the same time period for the payment service, we can see all the logs, and we can go to the error log and see that the payment failed because of an invalid API token. And indeed, we see that the token is a test token, and again, this is this version 10. Another thing that I want to show you is more related for a different service, and that's always on code profiling. So let me actually give us a little bit longer range of data that we can use. So for Java.NET and PHP, we can actually see code profiling and get a flame graph that shows us the CPU utilization of each line of code. And so if there's a problematic one, we can immediately see which line of code takes the most CPU usage and troubleshoot it. Similarly, we can have memory profiling, and we can need to choose the instance to monitor. And we can see the memory usage on that host based again on the line of code, and also a little bit based on time. So we see things like garbage collection, application activity, heap memory, or memory utilization. So that's it. And then I'll hand it off to Tanvi.
Thank you, Ori. So let's continue looking at some of the other problems that make it very hard to troubleshoot your microservices. And as we're doing that, please feel free to also add questions on the Q&A section. We do have some time at the end, and we'll be very happy to address questions then. So going back to why it's so hard to troubleshoot microservices, another problem that we've often seen is you don't have all of the data because either a service is not instrumented or data has been sampled out by your observability tool. And that really impacts troubleshooting things like databases. There's a few reasons why. So for databases in particular, you need visibility into each and every query and how that impacts your system to be able to tell where there's a bottleneck. In addition to that, we've also seen that queries perform a lot better when you're looking at them in an isolated test situation. But with real world traffic, larger data sets, and multiple customers accessing your system, the same queries can become very unperformant. And then thirdly, it's also very important to see how your database queries correlate with the underlying infrastructure, so you can see whether the infrastructure is healthy or if there's a problem with your infrastructure. So with Splunk, you can do just that. We've got a database query performance capability that gives you visibility into all of your queries, as well as the key metrics like total number of requests, P90s, and you could compare that with a previous point in time as well to see differences. With that, you also have visibility into the underlying infrastructure, so you can make sure that's healthy as well. And all of this is available out of the box without any additional instrumentation. So as soon as you instrument your services, we get visibility into your databases that are talking to those services as well. And we will show you how that works through a demo again. So let's dive into that. Let's look at how Splunk helps you isolate problems in databases. So let's say that I am interested in improving the performance for the order processing flow on my e-commerce website. Since this is a really important flow for my users, I want to make sure they can process orders smoothly. And I start on the service map where I can see all of the dependencies laid out for my application environment. On the map, I can also see the service that I'm interested in here, the order processor service. It seems to be taking 40 seconds to process incoming requests right now on the P90, and that is really high. It also looks like a lot of that latency is coming from the database that's talking to this order processor service. So to understand what's happening on the database, I go to the database service page, and over here I can see the red metrics for this database, as well as more specifically, I can dive deeper into all of the queries that are running on that database. So as we can see here, the query on top seems to be taking 1.4 minutes. That's so much higher than all of the other queries, and that seems to be what's causing the slowness on my order processor service as well. I can also see other metrics like the total number of requests coming and hitting this specific query, as well as other queries. And it does not actually look like there's a lot more requests going to this particular query. Most likely there is an issue with the query itself, so I can go work on optimizing that query. In addition to looking at the query performance, you can also look at the underlying hosts for that database and make sure all of your host metrics are healthy. All right, so now that we've seen some of the challenges with debugging your microservices, another question that often comes up in the same context is whenever you've got an issue, you want to understand how that's impacting your business as well as your users. And really, with a complex microservices environment like we just saw, you have multiple paths that your users can take. So sometimes you might run into problems where there's a subset of users having a bad experience, but other users are not. And you really want to understand even issues that impact a small set of your users, as well as you want to know how many users were impacted or what business metrics were impacted, so you can prioritize between different issues and pick the issues that are most impactful. So Splunk also offers a real user monitoring capability that gives you visibility into how your user experience looks like. And we do that through giving you visibility into all of your web vitals, as well as giving you access to all of the session data. So we do not sample, which means you've got all of your sessions and all of your traces, and you can find even those issues that impact just a small subset of users. There's also a session replay capability available with the session, so you're not guessing essentially what the user experience looked like, and you can see that in action, which ultimately reduces your time to problem resolution and identification. And then all of that is connected with the backend. If you've instrumented your backend applications, you get the full end-to-end visibility. So you can start at the front end, look at your user experience, and then if there's a backend issue, you can easily transition over to the backend to identify those issues as well. So it's all really connected seamlessly to improve your troubleshooting. And let's also see how that works. Let's go through an example of how Splunk helps you understand the user impact of application issues. So I'm looking at the real user monitoring product from Splunk, and over here I can see the most important web vitals for my application broken down by URL, as well as I can see how they've changed over a period of time compared to a previous time period. Now, it looks like the LCP has significantly worsened for two of my most important URLs in the last 4 hours or so. And I want to investigate this issue further, so I go to tag spotlight on RUM, and right out of the box, this view breaks down the LCP for that URL by various useful attributes like the browser as well as the location of my users. Because Splunk stores all of your session and trace data, you can be sure to see even rare issues that are impacting your system. So over here, I'm very confident that I'm seeing the full extent of impact on my users for this application slowness. And we see some interesting stats here. So it does look like Chrome has a lot more slow experience compared to the Safari browser. That issue seems to be worse on this particular version of the Chrome browser, as well as I can see that it is impacting users across a variety of locations with a much higher P75 than my users in London, for example. And then on the P99, I see that users in Sydney and Dublin are having a much worse experience. Now, to understand what is really going on here, I look at one of my user sessions, and on that user session, I can see all of the LCP vitals, as well as I can see the various calls that were made from the backend. Since my application is instrumented with APM as well, there is a link to the trace for the backend application that's being called here. And this particular call seems to be really slow, so I'm going to dive deeper into that specific trace to see what's going on. Now, as we can see here on the trace, there is a specific service and operation that seems to be taking majority of the time that was spent on this trace, and with that you can easily go from the front end issue to the back end application that is actually causing the issue, as well as see how that issue is impacting users across various locations that are trying to use your website. All right, so along with all the problems with debugging microservices, there's a very real tool sprawl with people who are using multiple observability tools, especially, and that tends to impact your troubleshooting again, because while you're troubleshooting, the last thing that you want to think about is getting insights across tools, learning a new tool, and really what you want is getting quick insights and solving the problem that you're looking to solve. With that in mind, we have recently introduced an AI assistant on the Splunk Observability Cloud product. So with the AI assistant, you can really treat it as a co-pilot as you're troubleshooting problems on Splunk, and you can ask questions, get quick insights into what's happening across your applications, metrics, traces, as well as logs, and really like avoid some of that context switch as you're troubleshooting. So very last demo, I promise, but let's look at how the observability assistant makes your troubleshooting easy now. Now we'll see how Splunk's new AI assistant helps you really reduce the mean time to resolution for issues in your environment. So let's say I'm a new engineer for my org, and my team is responsible for a bunch of microservices. I'm on call this week, and I get paged in the middle of the night, and it seems like the payment service is having a really high error rate. Now, as a new on-caller, I am unsure where to start my troubleshooting journey. So I lean on the AI assistant to gather insights from across my metrics, logs, and traces and really give me insights on what's wrong with the payment service. And as we can see here, the AI assistant has analyzed data across your observability environment, and it tells you things like the error rate for that service, as well as more detailed information on what particular errors you're hitting. In this case, it seems like there's a 401 error for my service, which is occurring in a particular version of the service. It also tells me other insights like what to look at next or possible solutions like rolling back the new version of my service. All right, so that basically wraps up some of the demos we had. And since we've gone through all the problems that we've typically seen, we'd also love to understand how some of these problems apply to you and your troubleshooting journeys. So if you can take a few seconds to answer the question on the screen here and tell us how the problems apply to you, that would be great. This is a multi-select, so you can choose as many problems as are relevant for you. This is the very last survey question, so hoping some of you can help answer this and tell us how these issues impact you. So I'll give you a few more seconds just for some of our other attendees to answer. Let's have a few more. All right, this is great. Let's see what we've got here. So since this was a multi-select, I see some of the options have a lot more responses here. Looks like sifting through data as well as alerts, looking at different tools, and the context switch that comes with it are very real problems for all of you. And then also prioritizing the right issues, which kind of aligns with what we've seen and heard as well. And hopefully with some of the other demos that you've seen here, you have the right tools now to address these problems. If you're interested in learning more, you can also talk to your Splunk account team, as well as you can sign up for a free trial of the Observability Cloud just to see how all of this comes together with your own data and as you're solving your customer problems. So we'd love to have you try that out. With that, we could switch over to answering some of the questions that we've heard. And if you want to add more questions as well, we're happy to take those as we're doing this. So let me look at...
In the meantime, let's maybe warm it up and answer a few questions that we see often asked when we speak with customers. Let me kick it off. How is the service map generated? That's something that I often get asked when I present these demos. Customers they see, or potential customers, they see the service map and they're curious how it's generated, whether it's a manual thing or not. The answer is, once you instrument the service, or a service, and then it starts sending data, then APM automatically sees that service and infers additional services around it and starts generating the service map by itself. So it's all automatically generated. You don't need to do anything manual to create that map. It's generated by itself. And then that leads to another question then, okay, how do I send data to Observability Cloud? And Tanvi, maybe do you want to take on that one?
Yeah, definitely. So it's really easy to send data to the Splunk Observability Cloud. There's basically two options you can use. For some of the most popular languages like Java, .NET, you can just install the OpenTelemetry auto instrumentation library. And after that's installed, your application would automatically start sending data to the endpoint that's been configured. And in this case, that would be Splunk Observability. And then in addition to that, you can also manually instrument by just adding a couple of lines of code to your applications where auto instrumentation isn't supported, or if that doesn't meet your needs. And all of that is also captured on our website on Docs. We've got a pretty extensive list of how you could instrument using both auto instrumentation as well as writing your own instrumentation.
Cool. We have another question about the AI assistant, and that's how to start it or install it in the Observability Cloud environment.
So with the AI assistant, it is available with the Ollie Cloud SKU. So if you've got Ollie Cloud, you can just get started with it right away. There's no separate enablement or SKU needed for that. It comes out of the box.
Okay.
And then, yeah, go ahead.
You can maybe take a stab at the next question as well about code profiling.
Yeah, so the question is there any capability for enabling profiling on demand? For profiling, you do need to add a Splunk version of the collector in terms of sending the data in. So whatever applications are instrumented with that version of the collector. And then in terms of languages, we do support a few languages, as Ori had called out in the demo. So if your application is using Java, .NET, or Node.js, you would use the Splunk version of the collector and then send us the data for that application for profiling to work. It is included in the APM SKUs. So if you have APM, you can start using it.
All right. One last question came in saying, I cannot find the AI assistant in our org. Should it be present by default, or does it need to be requested or enabled?
Yeah, if you
could be by default.
Yeah, if it's not available to you, if you could maybe share what org you're part of, we can take a look and follow up offline.
It should be on the top right corner. All right, and with that, I don't see any additional questions come in. So just before we wrap up, a few other upcoming events. There's another Tech Talk and also another office hours that's going to be dedicated for debugging microservices and observability cloud. Office hours are much more of a Q&A type of format. So you'll have the opportunity to chat with our engineers and really ask specific problems or issues that you're experiencing within your org, and they can help you troubleshoot and understand how to use the product. All right. With that, thank you all very much for joining us, and I wish you a great rest of your day.
Thank you all. It looks like there is one more question. We could take that over email, since I will just have to send you some documentation on how to send logs from MuleSoft to Splunk. We could share that offline. All right. Thank you all so much for joining.